Alright, we're going to look at now number 13. The figure below shows the first three stages of a fractal. How many circles will the nth stage of this fractal contain? First thing, there was some errors on the review. It should be 2 to the nth power for question B, and D should be 2 to the nth power minus 1. Now, I'm not going to go through a long drawn-out process of how to actually come up with these. What I'm going to do is kind of a test strategy. I'm just going to plug this in. So at stage 2, you should have, so n, if we let n be 2, I should come up with 3 circles. So 2 times 2 for my n, that gives me 4. So I know that's not it. You don't want to try the first one because usually the first one will work for all of these as just a test strategy. 2 to the nth power, so this would be 2 squared, which in this case happens to be 4. If I do 2 times 2 minus 1, that gives me 4 minus 1, which is 3. So that one works. Then let's try this one just to be sure that this doesn't work either. 2 squared is going to be 4 minus 1 is also 3. So I was able to eliminate A and B. C and D both work for stage 2. I'm going to try stage 3 since I got 2 of them that worked. So 2 times 3 is 6, minus 1 is going to give me 7. And let's see, 1, 2, 3, 4, 5, 6, 7. So that one worked. 2 to the nth power, or 2 to the third power. Actually, no, this is not right. That should be 5. 2 to the third power is 8. 8 minus 1 is 7. So the correct answer is D. Alright, now let's look at number 14. This is a right triangle. If the equation of the line containing ST, so here's ST, so there's a line going that way. Which of the following best represents the equation of the line containing RT? So go in this direction. Well, we have to look at our x-intercept, and all of these have an x-intercept of -1. So I know that I can't eliminate any answer choices there. Okay, but I do have to look at slope. So if I go from here and I go up 4 and then I go back 3, okay, it's rise over run, so this is going to give me 4. My slope is -4/3. So that means that my slope's -4/3, my y-intercept is -1. So that gives me B as the correct answer. Alright, moving on to number 15. The drama department at McKinney High School has built a stage. The length of each side is 4. What's the approximate area of the stage floor? For this one, the area is equal to 1/2 apothem times perimeter. This one's actually not too bad because they already gave you the apothem. That's 4.8. Perimeter, since it's 4, perimeter is going to be 4 times 8, which is 32. So this is 1/2, 4.8 times 32. And we put this in the calculator. We're going to end up getting 76.8. So that's B. Number 16. Which of the following conclusions can be drawn from the statements below using deductive reasoning? All squares are rectangles. The diagonals of a rectangle bisect each other. Okay, so this is kind of a logic thing. If I know I have a square and a square is a rectangle, and the diagonals of a rectangle bisect each other, that would just mean that the diagonals of a square have to bisect each other, which would be J. Now 17, we have a nice isosceles triangle. I know WY is 10 centimeters long. Find the length of XZ. So that's this right here. Alright, now because these two are both 13, and I know this is a 90-degree angle, this is going to get cut in half. So half of 10 is 5 and 5 on both sides. And then from here, it's going to be Pythagorean Theorem. So I'm going to do, we call this b, I guess. 5 squared plus b squared equals 13 squared. So b squared is going to be equal to 13 squared minus 5 squared. B squared is 144. If I take the square root of 144, I get 12. So 17 is C. All right, 18 talks about counterexamples. So if a quadrilateral has a pair of parallel sides, then it's a parallelogram. So we want something that is a pair of parallel sides, not slides. Then that's going to be something where I have parallel sides, but it's not a parallelogram. Square is a parallelogram, rectangle is a parallelogram, a rhombus is a parallelogram. Trapezoid does have one pair of parallel sides, and it's not a parallelogram. So trapezoid would be the answer for that one. That would be my counterexample. All right, number 19. Table shows how many triangles are formed when all the diagonals are drawn from one vertex into different regular polygons. Based on the table, which of the following statements are true? All the triangles formed in each regular polygon are congruent. That would not be true because of these. These are not congruent. All the triangles formed in each regular polygon are isosceles. Again, that might not be, that might be. Let's leave that there. Number of the polytriangles formed in any regular polygon is 2 less than the number of sides. So I have 3 sides and I have 1 triangle, 4 sides and 2 triangles, 5 sides and 3. So yeah, it looks like that's always 2 less. So that's another possibility. The number of triangles formed in any regular polygon is half the number of the sides of the polygon. Looking at that, that's not true. And looking at back to these two choices, if I look back at B, if this is a square, that's true. But what if it's a rectangle? This is just an example. Actually, no, let's take that back because it does say regular polygon. Okay, right here, this one though, this example right here is going to prove be false because this point right here would have to be longer than this distance here. So this one would be bigger than that one. So I could eliminate B. C is my right choice. All right, number 20. What is the volume of a similar rectangular box with the dimensions that are 3.5 times larger than the dimensions? This is like one of the other ones, P, A, V, 1, 2, and 3. So I'm changing all the dimensions and I'm looking at volume. So I want to cube that. So I'm going to take this box and I need to find the volume of it. It's going to be 4 times 12 times 10, which is going to be 480. So I want to do 480 times 3.5 to the 3rd power. Which comes out to be 20,580. So that is H as my right answer.